Good day, students and viewers. You are welcome to the studios of MathsX. We are still on number basis. In our last class, I taught you how to multiply in other bases other than our regular base 10 that we'll be using. I trust you were thoroughly enlightened. In today's class, my dear students and viewers, we will be learning how to divide in other bases other than our regular base 10. I trust that by the end of this class, all your doubts about division in other bases will thoroughly be cleared. But before we go on, as it is our culture, we would want to recognize our subscribers for the week. Thank you so much for giving this studio a lot of value. God bless you. Being done with that, let us begin. So, my dear students and viewers, for our exercises today, we have these exercises. So it says here, simplify the following. A, 142 base 8 divided by 7 base 8. B, 1232 base 4 divided by 23 base 4. C, lastly, 110102 divided by 1001 base 2, all in base 2. These are exercises we are going to try, my dear students and viewers. So for our first example, the A part, we have here that 142 base 8 divided by 7 base 8. I'm going to use the expansion method first. In the expansion method, I had taught you that you have a 0, 1, 2. This thing works on place values. This is a one-digit number, so this will be a 0. So, and then I'll begin my expansion. This is in base 8. So this will be 1 times 8 to power 2, which is this 2 up here, plus 4 times 8 to power 1, which is this one up here, plus 2 times 8 to power 0, which is this 0 up here, divided by 7 times 8 to power 0, which is this 0 up here. We have 1 times 64 because 8 to power 2 is 64, plus 4 times 8 because 8 to power 1 is 8, plus 2 times 1. By laws of indices, 8 to power 0 is 1. Then divided by 7 times 1, because 8 to power 0 is also 1, just like it was here. 1 times 64 is 64, plus 4 times 8 is 32. 2 times 1 is 2, of course, divided by 7. So this is 34, so 64 plus 34, that is 98. That is 98 divided by 7. 98 divided by 7 divided by 7. 7 into 9, 1 time. Into 28 is 4 times. So actually, 98 divided by 7, 98 divided by 7 is 14 times. This is in base 10, mind you. We need to convert back to base 7. And that process is a continuous division method. I taught you that earlier. So this is what we have here, that 7, 14, and our remainder r. So that 8 into 14 is 1 time, remainder what? 6. 8 into 1 cannot. We have a 0, we have a 1. Remember this? So that our 14 base 10 is actually 16 base 8. In conclusion, 142 base 8 divided by 7 base 8 actually is 16 base 8. This is how it is done, my dear students and viewers. Having done this in the expansion method, I would want to do it also in the regular division method. Our class today is going to be quite a package. I will take some space on this part of the board because we need to keep this for you to see. So same number, my dear students and viewers, but this time around, we'll be using our regular division. So we have here, I'm sure this looks familiar in whichever country you're watching from. So we have 142, of course, in base 8, then 7 base 8. Now, we're not counting in base 10, mind you, because you would have said 7 into 14, 2. That won't work here. But watch this and learn. Now, 7 base 8 into 1 base 8 cannot. So we'll bring in a second digit, which is a 2-digit number. Definitely, this number, 14 base 8, will be bigger than 7 base 8. Definitely. Now, let's try. Let's use a 2. For a 2, 7 times 2. Let's use our rough here. Let's take a rough here, please. 7 times 2, is 14. That's in base 10. But we are doing this in base 8. So you say 14 divided by 8, that is 1 time, right? Remainder what? 6. So 17 7 base 8 times 2 base 8 is 16 base 8, which is bigger than this number, 14 base 8. So we're going to use a 1. Remember, we had 16 base 8, so we have a 1. 1 times 7 is 7 because it is in base 8, so there is no problem. And we begin to subtract in base 8. 4 minus 7 in base 8 cannot. You borrow 1 from here. That 1 you are borrowing from here is 8. So we have 8 here now. 8 plus 4 is 12. 12 minus 7 is what? A 5. You bring down your 2, and we have a 2 here. So I have 5, 2 base 8. So 7 base 8 dividing 5, 2 base 8. I would have used this 6 as a guide, but let's test some numbers so you see what it means to test. Let's try a number like 3. 7 times 3, is 21. But in base 8, 8 into 21 is 2 times, which is 16. 21 minus 16 is what? 5. So too small. Let's go a bit higher. Let's try 4. 7 times 4 is 28. 8 into 24, 8 into 28, sorry, is 3 times. 3 times, which is what? 24. So what? Remainder 4. So you have 3, 4 base 8. Too small. So let's move to 5. I'll take another space here, please. Pardon me. Let's use 5. 7 times 5 is a 35. But your 8 into 35. So which means that doing what I do, you should have a good command of your times table. I said that previously in our class. All right. 8 rather into 35 is 4 times, right? 4 times remainder, that's 32. 4 times 32, remainder what? 3. That's 4, 3 base 8. Not good enough. Let's go for our 6, which is already what we have here. So let's use 7 times 6. 7 times 6 is 42. But 8 into 42 is 5 times, first of all. Remember what? 2. And that is exactly what we need here. So we have here a 6, and then 7 times 6 in base 8 will be 5, 2. We subtract and we have what is 0. So in conclusion, my dear students and viewers, therefore 142 base 8 divided by 7 base 8 is actually 16 base 8. That is what it is. Let's try another problem. But I've shown you the expansion method. I'm sure you are very comfortable with this method. Let us learn the division now. I don't really see myself expanding and then going through this, except I find it very necessary. So let's do this. Let's do the regular division so that we can learn. So for the next problem, the B part, that's 1232 base 4 divided by 23 base 4. So here we go again. We are dividing. 1232 at base 4, 23 at base 4. Now, 23 base 4 cannot go into 1 base 4. Too small. This is a 2-digit number. This is a 1-digit number. So it's not working out. 23 base 4 cannot still go into 12 base 4. Too small. Yes. So let's try the 3 digits. So the 23 base 4 can go into 123 base 4. But let's find out how and which numbers. Let's try a 2. 23 times 2 is 20. Let's do this. 23 times 2. This is base 4. 2 times 3 is a 6. We are counting in base 4, right? So 6 divided by 4 is 1. Remainder what? 2. 2 times 2, 4, plus 1, 5. 5 divided by 4 is 1, remainder 1. Hey, it's close. It's close. So, but let's try 3 just to conclude. How about 3 times 3? Mind you, all of them in base 4, please. We are counting in base 4. This is 3 times 3 is 9, right? 4 into 9, as in 9 divided by 4 is 2 times remainder 1. So that's my 1 carry 2. 2 times 3, 6, plus 2, 8. Then 4 into 8 is 2 times remainder 0. So I have a 20. So we have 201, which is bigger than this. I believe this is the number I should pick for now. So using 2. So let's write a 2 here. So 2 base 4 times 3 base 4 is this. It will be 112 base 4. We are subtracting. This is a 1. This is a 1. And bring down this, and we have a 2. This number looks familiar. Hey, I did this earlier. See it here again. So I don't have to stress myself. So I'll use simply a 2 again, and I have a 112. And we have a 0. So my dear students and viewers, 1232 base 4 divided by 23 base 4 is equal to 22 base 4. How is that? Of course, you can still use the expansion method and still get it. But our emphasis in today's class is on this division. So I want us to learn. Let's try another example. So my dear students and viewers, for our last example here, we have 110 at base 2 divided by 1001 still at base 2. This is a 4-digit number, my dear students and viewers. So to use a 1-digit number to divide a 4-digit number. So my dear students and viewers, this is what we're going to work on. So 1001 in base 2 divided by 1 in base 2, it won't work out. This is a 1-digit number, this is a 4-digit number, it's not going to work out. 1001 base 2 divided by 11 base 2 still won't divide, cannot, because this is a 2-digit number. 1001 base 2 divided by 110 base 2 still will not sit well. It cannot, because 110 base 2 is a 3-digit number. It cannot. But 1001 base 2 divided by 1101 base 2, that's a fellow 4-digit number. And look at it by appearance, 1101, 1001. This is definitely bigger. So it can divide. But we are counting in base 2. So the highest notation is going to be what? 1. So we use a 1 here. So 1 times 1001 will be 1001. We subtract. We have a 0, and a 1. Bring down this 1 here. It's the same digit. So we don't have much to think about. So this will be a 1. That will be 1001. And this is a 0. We need to bring down this. So we have a 0. A 0. So 1001 into 0 cannot, that's a 0. So your answer remains a 0 there. So in conclusion, my dear students and viewers, 110110 base 2 divided by 1001 base 2 is equal to 110 base 2. My dear students and viewers, I'm sure you've seen how I have divided these numbers. For the first example, the A part, I had to use the expansion method to show you that, hey, this can be done this way. But our emphasis, my dear students and viewers, is on use of division involving other bases, which is what I wanted you to learn. In our next class, we will be using number bases to solve problems. All that we have learned in these classes involving number bases, because sincerely we've covered all the aspects of number based systems. So we will be solving problems from WASE, Cambridge, and NECO examination bodies, just to put you on the right footing. That's what we'll be doing in our next class. Until we meet again, my dear students and viewers, keep watching the videos of MathsX, like, share, and of course, subscribe. As you do so, God bless you.